You start with 2.5 milliliters of glucose, which is C6H12O6. The density of glucose is 1.54 grams per cubic centimeter, or milliliters. You have 3.85 grams of glucose. You put this 3.85 grams of glucose into 44 milliliters of water with Cl2 because it's chlorinated, an approximation of 2 parts per million in 7.6 pH solution. There are 44 grams of water, 2.4 continuing moles of water for every, and there are 2 parts per million chlorine in that 2.4 moles. There are 1.45 times 10 to the 24th parts of water, and for every that many parts of water, there are 2.89 times 10 to the 18th parts of Cl2, which is because chlorine is always diatomic. Alright, next assumption. You said that approximately the decrease was 1.3 pH in the 44 milliliters water solution with 2.5 milliliters of glucose. Here's how you determine, here's 5.682 milliliters glucose over 100 milliliters of H2O, which is this, to make it even. It's easier to deal with things when they're at 100 milliliters at the bottom. 3.85 grams of glucose over 100 grams of water. Here's the same thing I sent you previously. pH lowering is caused by glucose plus diatomic chlorine goes to 2 hydrochloric acids, 3 carbon dioxides, 2 methanes, 1 carbon, and 1 diatomic hydrogen. Now, the next thing, which I don't really have written down yet, I'm going to write it while I'm taking this. pH of chlorine, it's already written up there, HCl, is equal to the average pH when it's just by itself in the solution is 2.25. Now, the decrease is 1.3. So what I did, I took the parts 2.89 times 10 to the 18th, and I divided that by the decrease in pH, which is 1.3 pH. And that equaled, and I feel like this can't just be a coincidence because of how perfect it was, 2.249, which is the pH of HCl by itself. So I think I have determined why glucose has lowered the pH of 7.6 pH, 2 parts per million chlorine water.